resolution, and I'm super excited to have you back with me here. Today we'll be solving a question under the resolution of forces, uh, which can be found under, I think it's moment. Moment. Resolution of forces is also in moment. Where we have this parallel non-coplanar forces. Okay, so the question goes to us: the body X shown in the diagram has a mass of 6 kg. The body X, the body is here. This is the X here. The X is here. So it has a mass of 6 kg and is held in equilibrium by a strong and horizontal force F. The tension in the string is, or to find tension in the string. We'll also try getting the force F also. Okay, now to solve this question, this is a non-coplanar, non-coplanar forces. So as we know that we have two conditions for this object X to be in equilibrium. See now, as we have been given the question that the body is in equilibrium, and since we have two conditions for the body to be in equilibrium. The first one says that the algebraic sum of the forces in the x direction must be equal to 0, and also the algebraic sum of forces in the y direction must be equal to 0, which means that sum of forces in the vertical direction, sum of forces in the upward direction must be equal to the sum of forces in the downward direction, and also the sum of forces in the right hand side must be equal to the sum of forces in the left hand side. Now, taking our own case here, we are given the mass of the mass of the object, which is 6 kg. So if we have 6 kg of mass here, I'll do my color. We have 6 kg of mass here. So the weight with which that mass will be acting downward will be 6 times 10, which is 60 Newton. So this object here is acting downward with the weight of 60 Newton. Now, this is the only downward force we have here, which is the weight of the object. Now, the upward force we have in here is when we resolve this tension here vertically. And to resolve it vertically, we have something like this, right? This is what we are having there. We have 30 degree here. This is our T here. So to resolve it vertically in this direction, we can simply just take this. So this is our Fy. Want to resolve that force? We want to find the tension force that is acting vertically in the vertical direction. So the angle between here is 60. So to resolve this now, let's try sin theta. Sin theta equals to what? Opposite. The opposite in this case here is Fy over, and the hypotenuse is tension, which is T. So our Fy is equals to T sin theta. Remember that the theta here is 60 because we're using this theta here. So the upward force, now the force in the upward direction is T sin theta. So since initially we said the condition for equilibrium is that the upward force must be equal to downward force. So we can say the downward force. So let me just put it out. Upward force equals to downward force. The upward force here is T sin theta is equals to downward force here is 60 Newton. So now this is how we will find our T. So let me just stop here for this video and I'll move further in the next video. Catch ya later.